Hello, in this video I'm going to talk about calculating truth values, which is an important part of using truth tables. What's calculating truth values? That's what we're going to find out and how to do it. So, remember we're interested in tautologies, and what is a tautology? A sentence that is true in every situation that is false in no situations. So, what's a truth value? Well, it's actually simple. It's a convenient way of talking. As it turns out, that is just a different way of saying something we're used to saying. So, if a sentence is true, then we'll say that the sentence has a truth value true. And when a sentence is false, we'll say that the sentence has a truth value false. So it's just a different way of talking about sentences being true and false. But there are two assumptions we're making, that there are two truth values, true and false, and no others. And then in each situation, each sentence has exactly one truth value. It's true but not false, or false but not true. Those are substantial assumptions, but we're going to make them. So we have this idea of truth values, and it's just a different way of saying a sentence is true, a sentence is false. But it turns out to help in describing certain things. Okay, so let's take this sentence P and Q and not R. So this is a big sentence, and we might wonder, how am I going to find out its truth value? Well, I'm going to tell you how, and then I'm going to show you how it works, and then I'm going to tell you again. So, what do we do? Well, how do we calculate its truth value, i.e. find out whether or not it's true or false? Well, we do it using, first, the definitions of negation and conjunction, which we have from the previous video. The truth values of P, Q, and R individually, so they're each going to have truth values, and then the grammatical tree of the whole big sentence. Remember, that's what we've talked about in the parsing module. The tree shows how the whole sentence is built up from sentence letters. So we use those three things together: the definitions of negation and conjunction, the truth values, whatever they may be, of the three sentence letters, and then the grammatical tree of the whole big sentence. And what we'll see is that the truth values start at it's an upside down tree, and so the truth values start at the bottom with the sentence letters, and then they go up the tree, this upside down tree, they go up the tree until they get to the whole sentence at the very top of the tree. So let's take a look at that. Okay, so here's the grammatical tree for the sentence P and Q and not R. The whole big conjunction it's a conjunction of not R on the one hand and P and Q on the other hand. So that's what we have here. We have P and Q and not R broken up into P and Q on the left and not R on the right. But then P and Q has two parts, P and Q, and not R has one part, R. So this tree breaks the whole big sentence down into its individual pieces, all the way down to the sentence letters out of which we built the big sentence. Okay, now let's suppose that we knew what the truth values of P, Q, and R were. Suppose that P was true, and Q was false, and R was false. Okay, well, if P is true and Q is false, then what's the truth value of P and Q? It's false. The only way the conjunction P and Q is true is if both of its parts are true, but one of its parts is false, namely Q, and so the conjunction P and Q is false. And what about not R? Well, R is false, and the negation reverses the truth value, so not R is true. Okay, so the truth values have gone up one layer of the truth table to the middle layer. And now they're going to go to the top. If we look at the top, we see the top is what? The main operator of the top is the right conjunction. It's a conjunction of P and Q with not R, so that the rightmost conjunction sign is the main operator, and it's conjoining P and Q on the one hand and not R on the other. So it's a conjunction, and so if we look at it, we say, well, okay, the right conjunct, negation R, that's true. Okay, the left conjunct is P and Q, and the left conjunct is false. So the top thing is a conjunction with one false conjunct, namely P and Q, and one true conjunct, namely not R. So we have a conjunction that's false and true. Well, if a conjunction is false and true, then it's a false conjunction, because a conjunction is true only if both sides are true. And so this whole thing is false. So what we see here is that the truth values, once we find out what the truth values are for P, Q, and R, then we can use our definitions of negation and conjunction to make the truth values go up the tree until they get to the very top. And then we know, okay, when P is true and Q is false and R is false, then the whole thing is false. Okay, so that's how it works. Now, let's think about this for a second. What doesn't matter here? Do we know what P, Q, and R mean? No, we don't. We haven't said what English sentences they're being used to symbolize. They could be used to symbolize all sorts of sentences. We didn't find out what their meaning was, but we didn't need to. We didn't care. What mattered were the truth values, and the truth values of P and Q, the truth value of the conjunction P and Q says, I don't care what P and Q means, just tell me what the truth values of P and Q are. The truth value of negation R says, I don't care what R means, just tell me what R's truth value is, and I will tell you what my truth value is. So whatever P and Q and R mean, we know that given the truth values that we assigned, P is true, Q and R were false, then the whole thing is false, because P is true while Q and R are false. And it doesn't matter what P and Q and R mean. We don't care, so we don't bother to say. Okay, now let's look at a different tree, or a different sentence in a different tree. So this sentence is Z and U and not Y. So this is a conjunction, one of whose conjuncts is Z and U, and one of whose conjunct is not Y, so the whole thing breaks down into Z and U on one side and not Y on the other, and then those break down again. So Z and U breaks down into Z on the one hand and U on the other, and not Y breaks down into Y. And so this tree shows how the big conjunction was built up from Z, U, and Y with these intermediate stages. Okay. This should look very familiar, right? It just looks just like the previous P, Q, and not R, except we've replaced the P with the Z, the Q with the U, and the R with the Y. But it's the same. Besides that, it's the same. And let's suppose that we said that Z was true, and U was false, and Y was false, just like in the previous example with P, Q, and R. Well, then the intermediates would also be the same. So in the previous example, we had P and Q was false. Now we have Z and U being false because U was false. In the previous example, not R was true. Here we have not Y being true because Y is false as opposed to R's being false. And then the whole thing is false because its left conjunct, Z and U, itself a conjunction, is false, and so the whole thing is a conjunction with a false conjunct, and that's a false conjunction. Okay, so this shows us some more things that don't matter. Not only it doesn't matter what P, Q, and R mean, it doesn't even matter that it's P, Q, and R. All that matters is the truth values of the atomic parts and how the tree is put together, and our definitions for negation and. Okay, so the logical language is special in this way. Every logical sentence is like P and Q. So we have this big sentence, P and Q and not R, and all the logical sentences are like P and Q and not R in the following way. The truth value of the whole thing depends only on the truth value of its atomic parts, of the sentence letters. It doesn't depend on anything else, given what we've said about the meanings of negation and. Okay, so sentences that are like this are called, that is, if the truth value of the whole thing says, well, tell me what the truth values of the component parts are, and I'll tell you what the truth value of the whole thing is. They're called truth functional, because the truth of the whole thing is a function just of the truth of its pieces. I'm confused. English is not truth functional. Let's have an example. Okay, so let's say I have a shadow because the light is on. Well, do I have a shadow right now? Yes. Is the light on? Yes. And not only are both the pieces true, but the fact that the light is on is part of what's making me have a shadow. Yeah? Okay. Now let's say I have a shadow because I lived in Boston. Well, it's true that I have a shadow right now, and it's also true that I lived in Boston when I was younger, but this sentence is false. Yeah? So now let's think about these two sentences. I have a shadow because the light is on. Both parts are true. I have a shadow is true, and the light is on. And the whole thing is true. So both parts are true, the whole thing is true. How about I have a shadow because I lived in Boston? Well, for me, both parts are true, but the whole thing is false. So we have two sentences, two because sentences. The pieces have the same truth values. In both cases, both parts are true. I have a shadow is true, the light is on is true, I lived in Boston is true. So all the pieces are true, but the two sentences have different truth values. Okay, that means that the whole thing, because sentences are not truth functional, right? You say, here's what the truth values of the parts are, and then you ask, is the whole thing true or not? You say, I don't know. It's not enough to know that the two pieces are true. They have to be connected in the right way. And the sentences of the logical language are not like that. They're much simpler. They say, I don't care about the connection. Just tell me whether or not my pieces are true, my pieces are false, and I will tell you whether or not I am true or false. Because sentence says, no, no, no. Yeah, if I'm going to be true, both of my pieces have to be true, but they also have to be connected in the right way. And I have to do further investigation to find out whether or not they are connected in the right way. Okay? So you couldn't do a truth table for a because sentence. You couldn't do a truth tree for a because sentence. You can for our sentences because they're truth functional. All that matters to the truth of the whole thing is the truth of the parts, the truth of the atomic parts, the truth of the sentence letters that make it up. So, if we want to know whether or not one of our sentences is true in a particular situation, then we have to find out the truth values of the sentence letters in that situation. And then we use the definitions of negation and conjunction to determine how the truth values go up the tree. Okay, so we find out the truth values of the sentence letters, and then we use the definitions to make the truth values go up the tree. And they'll go all the way up the tree, as we saw, and then the whole thing gets a truth value. And this is all possible because negation and conjunction are very special because they're truth functional. Okay, so in the next two videos, I'm going to talk about actually finally using truth tables and actually doing a whole truth table. So we'll see what those are like in the next and last two videos.